Alright, the chaos that is Webassign. What I want you guys to take a look at. So I won't be there on Monday. My son's daycare doesn't have school, which is weird. So I will be with him. Probably not answering emails because 2-year-olds are distracting, so heads up. Okay, first thing I want you to realize, note 7, I didn't teach it. I'm not going to teach it. It won't be on the test. Just leave it alone. It was my bad. I put it on, it was a preset assignment, and I thought I skimmed through all the questions, and I totally missed that one. So please don't freak out about 27. Alright, we're finding hangouts. I say 31 and 24, which is not clearly numerically in order. And I don't even know which one this is. But if you've done the Webassign, which is, 42 minus 11. So, 30 of you have done this? I know because I saw. Okay, so you know this problem. You read this story about Harry and Angela. Okay, it's really important that you draw a diagram. On the test, you're going to need to draw a diagram. So, here's a balcony, right? And there's Harry and Angela. They're taking a look at this balcony, and they see a swimming pool over here. That's a swimming pool. Okay, so they roughly estimate the balcony is about 40 meters high. Okay, they also roughly estimate, so this is highly inaccurate, so I'll do this. So again, vector quantity should have a magnitude that makes sense. So I need to redraw my pool. So if you don't understand why I did that, this should be about half the size of this. I'm not measuring, I'm not going to waste your time doing that right now. But we know it's about 20 meters, this distance. Okay, they're trying, a lot of you guys are like, oh, easy, Pythagorean theorem, right? But they're trying to figure out how fast they would jump. Okay, so let's go through the need to know. This is when I want you guys to pay attention. We've learned about the vertical component and the horizontal component. They are important. And the reason, right, we can't do a resultant. So like, oh yeah, you do a resultant, do my little square, make it work. A squared plus B squared equals C squared. All of those things have to have the same unit. So yeah, you're going to figure out the distance that connects, them, but that's not what you want to find, because remember, this is in meters and this is in meters. So the answer will be in meters. Well, they want to know how fast. So what we're trying to find is velocity. So the things I know the distance of the horizontal. The horizontal component is 20 meters. The distance of the vertical component is 40 meters. And these are important. It's important to pay attention to the direction of things. Okay, you also know the gravity thing, because gravity, if they jump off a balcony, stupid, but if they jump off a balcony and hope to hit the pool, 40 meters, guys, that's a really far drop. That would hurt. The force of the pool would just flippin' hurt. But if you did it and managed to hit the pool and live, this is a projectile motion. So, in order to figure out the velocity of this, we're going to need two equations. Well, inherently, you know the horizontal component is the same every time. So you can use the equation v equals distance over time. And you have distance, right? This would go into here. What you don't have is time. So we need another equation. how can I figure out time? Well, if they just jumped off a balcony and fell 40 meters, you'd be able to calculate the time for that. So, come up with your 2d divided by g equation. So now this is a two-parter. Your time is equal to the square root of 2d divided by g, because we're trying to figure out how much time it took them to fall. Right? So if I take this and I plug and chug, square root of 2 times, what is the first distance? What distance matters here is the vertical, because this is free fall, remember? So 40 divided by 10. T equals square root of 80 divided by 10. T equals the square root of 8, right? 10 into 80 is 8 times. And T, pardon me, need a calculator here. I don't think you can see this. Square root of 8. 2.8. So time is about, sorry if that, is it so? Sorry, I stopped my recording when I went to switch for the calculator. It's about 2.8 seconds, give or take. Alright? Now that we have time, I can throw time up here because I know it now, 2.81 seconds. Now, I can utilize that for my velocity equals distance divided by time. Because remember, this motion can be split into a horizontal, which is constant, and then a free fall, which you know has gravity playing a role here. Okay? So V equals, so we have to use the horizontal. How far do we have to go? 20 meters divided by 2.81 seconds. Velocity is approximately, bear with me here, when I did it on the computer, it wasn't going to do it. We have 20.81, 7.1 meters per second. Approximately. Okay. Here's my second question. This is the same deal. Okay. There's the horizontal vector and the vertical vector. No, horizontal vector, which in this case, so everybody has it a little differently, is 62 meters. That's how far that ball went. The height is 18 meters, right? So, things we know. Distance, horizontal, is 62 meters. Distance, vertical. Guys, this is why I really want you to label your numbers. Distance of the vertical component is 18 meters. Gravity is 10 meters per second squared. And again, you're going to need the time factor. You're going to figure that out. So your ultimate is you're trying to find velocity. That's your question. Same situation. You can figure out, so when you divide this motion into horizontal and vertical components, you have this, which is constant, and this, which is free fall. Okay? So, let's pay attention to this. Equations, time. I want to figure out how much time it took to fall 18 meters. 2d divided by g. And velocity is distance divided by time. Okay? Remember, I can just use bits and pieces of the information. So, last one. Time is equal to square root of 2d divided by g equals the square root of 2 times The distance, okay, don't get this distance wrong, it's 18. Because that's the free fall distance divided by 10. T equals square root of 36 divided by 10. T equals square root of 3.6. T equals, go calculator. Sorry, no, I'm not good at mental math. Quick and easy stuff. Clear it out. Square root of 3.6. If you got this faster than me, you're rocking it. 1.9. I'm going to round up to 1.9. So there's only two significant figures here. Okay, there's my seconds. Don't forget my units. There's answer part 1. 1.9 seconds. Now I can do V equals distance divided by time. This time, this one matters because it's velocity of the horizontal component. How fast did they throw it straight out? If there's no gravity, it wouldn't fall and it would be still going at whatever we calculated. V equals 62 meters in 1.9 seconds. You figure out that's approximately, just by mental math, about 31 meters per second. So I'm going to say approximately 31 meters per second. It's going to require you to be more accurate than that. Probably go to decimal places. But for a quick and easy explanation, here you go. Alright, those are the two hardest ones. And I'm not sure there's even one of these on the word portion of the test. There might be one, so pay attention. They're asking for velocity on a parabolic motion, and they give you two distances. Do not do the Pythag, because velocity is meters per second, and the distances are meters. They're not the same units, so it's not going to tell you the velocity. Hope this helps.